Good afternoon, good evening, good morning, 8 Hail Math students. This is looking at solving systems by elimination or linear combination. So we are going to eliminate one variable by adding the two equations together. So the thing you need here is for your x or y variables to have opposite coefficients. So here I have 1x and 1x. Same, not opposites. 1y, negative 1y. 1y, negative 1y. Opposites. So we can go here, where we combined our equations. So 1x plus 1x is 2x. 1y plus negative 1y is 0, cancels out, equals 28. So now I can divide both sides by 2, and x is equal to 14. So then, as I did in substitution, I'm going to use this 14 in one of my original equations. I like to keep things positive, so I'm going to plug the 14 in to the first equation. Equals 18, subtract 14 from both sides. Y is equal to 4. So my final answer for that first one is the ordered pair 14, 4, right? And 14 minus 4 is 10 if I want to double check with that second equation. Now it gets a little trickier when your original equation does not have opposites, 2, 6, 3, 5. So you need to multiply one or both equations, and you have to multiply that whole thing so that you have opposite coefficients. So I'm going to multiply the top equation by negative 3 so that I have a negative 6x and a positive 6x. So that's negative 6x plus negative 9y equals negative 36. And then the other equation stays the same. 6x plus 5y equals 20. So now I have my opposites, so I can combine. So let's see. Negative 6x plus 6x is 0. Negative 9 plus 5 is negative 4y equals negative 36 plus 20 is negative 16. Then I divide both sides by negative 4. Y is equal to 4. Right? Negative divided by negative is positive. So now I take my 4 and go back to one of my original equations. I'm going to use the first one, 2x plus 3 times 4 equals 12. So that's now 2x plus 12 equals 12. Subtract 12 from both sides. 2x equals 0, so x equals 0. So our final answer for the second problem is 0, 4. And again, you can take those numbers and double check with the other equation, right? 6 times 0 is 0. 5 times 4 is 20. 20 equals 20. Alrighty, let's take a look at a linear equation or a system of equation word problem where you would want to solve using elimination. So here the Patriots scored 33 points from 7 scoring plays. The plays were either touchdowns, and we're going to assume the extra point was made, and field goals. So you have your x touchdowns, your Y, field goals. You can do it the other way around. Just make sure you're labeling or writing down what's what. So equation 1 is 7 scoring plays made of touchdowns and field goals. So that's your X plus Y equals 7. Equation 2 is that you get 7 points per touchdown plus 3 points per field goal for a total of 33 points. So now we can put those together and we're going to solve using elimination. So I'm going to multiply the bottom equation by -3 to eliminate my y's and keep everything else positive. So we get 7x plus 3y equals 33. And then we have -3x plus -3y equals -21. So now we add them. So that is 4x equals 33 minus 21 is 12. Divide by 4. So x is 3. So x equals 3 touchdowns. Then I use that 3. I'm going to go back to this equation. My x plus y equals 7. So 3 plus y equals 7. Subtract 3. Y equals 4. Apparently I really liked y equals 4 in this problem, in this worksheet today. Didn't do that on purpose. So that's 4 field goals. Ta-da!